Good morning everyone. In this lecture we have to see about the design of shear and torsion. Myself Dr. J. Sahayaruban, Professor and Head, Department of Civil Engineering, Rohini College of Engineering and Technology, Kanyakumari. Behavior of shear in RC members. When the shear failure occurs, when the beam has shear resistance lower than the flexural strength, and the shear force exceeds the shear capacity of the different material of the beam. Normally, the load is acting in the downward direction. The shear failure happen in the beam column joint. Three different types of shear failure occur in the beam normally. One is a shear tension failure, shear compression failure, and third one is diagonal tension failure. The figure indicates first one is the shear compression failure, second one is a shear tension failure, third one is a diagonal tension failure of the beam. Let us see about the nominal shear stress. The nominal shear stress tau V we have to calculate by using this relation Bu by Bd, where tau V is equal to nominal shear stress. Bu is the shear force due to the design load. B is the breadth of the member, which for flange section shall be taken as the breadth of the web BW. D is the effective depth. So this is regarding a nominal shear stress. This is clearly given in the IS 456 2000 class 40.1. The nominal stress, in case that beam having the varying depth, we have to calculate by using this relation, that is tau V is equal to Bu plus or minus mu by d into tan beta divided by Bd. So tau V is the shear stress, V is the shear force, then B and D is the width and depth of the section, M is the bending moment at the section, beta is the angle between top and bottom edges of the beam. The design strength we calculate by using this relation, that is Vc is equal to tau C into B into D, where tau C is the design shear strength in Newton per mm square. This value we get it from the table number 19 of IS 456 2000, page number 73. For that, we first calculate the percentage of steel reinforcement, that is 100 AS by B into D. From that, so different grade of concrete is given, M20, M25, 30, 35, 40 and above. We have to determine the tau C value, that is design shear strength, tau C value we have to calculate by using this table. The value we get it from in Newton per mm square. Design of shear reinforcement given in IS 456 2000, page number 72. When tau V exceed tau C, we have to determine the value from table number 19. The shear reinforcement normally we have to provide it in three forms. One is a vertical stirrups, another one is a bend up bars along with stirrups, then finally inclined stirrups. So these are the three type of stirrups we have to provide for reinforcement. Then for a vertical stirrups we have to use this relation to find that shear strength, that is Bus is equal to 0.87 Fy Asv into D divided by spacing of stirrups. In case of inclined stirrups or series of bars bent up at the different cross section, we use this formula to determine the Vus value. That will be is equal to 0.87 Fy Asv into D divided by Sv into sin alpha plus cos alpha. That case is for a single bar or single group of parallel members all bent up at the same cross section. This case we have to use this one formula, Vus is equal to 0.87 Fy Asv into sin alpha. So these all cases for a vertical stirrups, for inclined stirrups with a series of bars bent up, then for a single group of parallel bar. This is clearly given in page number 73 of IS 456 2007. The minimum shear reinforcement for the stirrups is provided. We have to calculate from class 26.5.1.6, that is ASV divided by B into SV is greater than or equal to 0.4 divided by 0.87 Fy. ASV is the total cross sectional area of the stirrups legs effective in shear. SV is the stirrup spacing along the length of the member. B is the breadth of the beam or breadth of the web or flange beam BW. Then Fy is the characteristic strength of the stirrups, which shall not be taken greater than of 450 Newton per mm square. The behavior of rectangular RC beam in shear and torsion. It is given in page number 75 of IS 456-2000, class 41.3. VE is equal to VU plus 1.6 into TU by B, where VE is the equivalent shear, VU is the actual shear, TU is the actual torsional moment, B the breadth of the beam. The equivalent nominal shear stress, that is tau VE, is determined by using VE by BD. Normally the tau VE shall not be exceed tau C max. The value is given in a table 20 of IS 456-2000. The longitudinal flexural tension reinforcement shall be determined to resist the equivalent bending moment MEL is given by MU plus MT. MU is the bending moment at the cross section. Then MT is equal to TU by 1.7 into 1 plus D by B, where TU is the torsional moment, D is the overall depth of the beam, and B is the breadth of the beam. The transverse reinforcement is given in class 41.4.3 of IS 456-2000. ASV is equal to TU SV divided by B1 D1 into 0.87 Fy plus VU SV divided by 2.5 D1 0.87 Fy. However, the total transverse reinforcement shall not less than this one. This is ASV greater than or equal to tau VE minus tau C into B into SV divided by 0.87 Fy, where TU is the torsional moment, VU is the shear force, SV is the spacing of stirrups, then B1 is the center to center distance between corner bars in the direction of width, and D1 is the center to center distance between corner bars. Thank you.